Hey guys, I'm Adik Mewada and I'm the founder of Smowcode. I'm here to introduce you to Smowcode, its basics, its advanced concepts, and how what are things you need to know before you begin using Smowcode. So let me introduce Smowcode to you first. It's a graphical way of coding microcontrollers. You guys use a coding language. We've created one. Yes, we've created our own new coding language. We've created a fully integrated IDE where you can code as well as upload your codes onto the microcontroller. You can download the binaries. You can generate the source code. It's a compiled language. There's a compiler that converts your code from whatever graphical code that you create from SMO file to binary file at the end. It first converts it to C language and then to binaries. This is how Smowcode works internally. Smowcode's way of coding, so which paradigm it follows. Smowcode uses flow-based programming method. So over here, it's not block-based; it's flow-based. So whatever flowchart that you create on Smowcode, that it's a sequence of flowchart. So you can just go on adding more and more nodes. We call these blocks as nodes in Smowcode, and these nodes you can just keep connecting and they'll run in a sequence. And because it's flow based, you can go on adding more and more flows in your system, in your code, and they will run parallelly as well. So we are a flow based coding language where you can even branch out, branch in. You can do quite a lot of items in Smowcode. So the paradigm of Smowcode is clear. What Smowcode does is clear. Now, how it was founded. When I was young, I was in my diploma. I was doing an internship in embedded systems, and my boss used to write a logic diagram on a sheet of paper, and I used to write thousands of lines of codes based on it. So my boss used to write this logic diagram within a minute or half a minute or something, and he used to leave. And I had to write for days and days, months as well at times, based on that logic diagram. The creation of logic was so easy. Now I thought that there should be a coding language which is easy to use, which just requires that logic, just the diagram, and that should be it. So we've created this now, and that's where we were. That's how we started Smowcode. This was my second year engineering, and from then we've been adding more and more tools and features onto our system for you to be able to gain access of more and more features of coding. uh, so in Smowcode, you don't just get to create codes in graphical way, you get 100% accessibility. So when Smowcode was founded, we made sure that we are making it for industries. This is not made for kids, this is made for industries. Yes, obviously it's easy, so kids might even try, can try as well. And we have something for them as well for education, but that's just to educate them about Smowcode. Smowcode is majorly for industries, else we would have made this for in 6 months and not taken the 5 years that we have taken to just make it for kids. So Smowcode is 100% flexible, 100%. It provides 100% accessibility to all the low-level items of microcontroller, peripheral settings, configurations. You can access registers on Smowcode. You can access the source code. You can generate binaries. You can generate source code, create the source code, or get the source code. Basically, it's not the AI generation wala source code. It's proper compiled source code from Smowcode. There's an upload button as well, which you can upload onto your microcontroller. There's debugging features. There's so many free RTOS, as in RTOS based. It's made for complex applications. Um, so we've covered how Smowcode was found. We've covered what what is Smowcode, why Smowcode, and let's see the idea of Smowcode. So how you have to use Smowcode is you have an idea, okay? You have an idea, and you have to first capture. Wait, let me just open Notepad for now. So you have an idea. You need to get from an idea. You should know the features of your project. Once you know the features of your project, all you need is then the components that your project will need, the hardware components that your project will need, the hardware components. Once your hardware components are known, these are things we assume that you know from first before beginning your project on Smowcode. This is something part of your logic which you have to do. It's part of your work here. So once your idea is known, once your features are known, once you know the hardware components list, then you should know how you want to connect them. So it includes, let's say, I2C, GPIO, analog, or let's say SPI or UART, or any, let's say, Ethernet or MQTT, or you should know how to connect the components. It might include internet, cloud, or server as well. How to connect it, what is the sequence of communications, if any, with any peripheral. You should know all these items. Now you know exactly how things are connected. You have a diagram. Okay? You should have a circuit diagram or something in your hand. After you have these all items in your hand, this is how you will be able to make things using with speed on Smowcode. You so all we our job is to ensure that once you know all these things, there's nothing else that's pending from. So there's not much delay on Snowboard's end, on the coding end. That's what we ensure. Your firmware development is what we help you with as of right now. We would like to get into these segments as well, but we're yet to get there. Circuit diagram done. Now all you need is logic. Okay, you need to develop, you need to think of the logic. Now, I'll explain you how you should think the logic. Okay? Now, how should you think the logic? Now, to think the logic, you need to first understand what are activities are there per feature. Which activities are there per feature? Which activities per feature? When should these activities happen? Which is nothing but the events. So, we need to know the activities and we should know the events on which these activities should happen. Once you know this, your logic is developed. Yes, you will need to know even a few things. Let's say if any data has to be taken, given, processed using a formula or something. Okay. Yes, you need to know that this as well. An event comes, you have to perform this activity after doing some data that has been taken from the event. Okay, let's say some temperature has been taken. So once you know this logic, then you begin learning how you begin creating your code on Smowcode, code for your logic on Smowcode. Now there's a little thing that you should do first is go through the activity and event nodes uh, on how to use them, and their example projects. This will help you a little when you are new to Smowcode. Okay, and the example projects. Once you use this, if you are new to Smowcode, you should do this. Okay, I highly recommend. If you don't see a project or a node that you would like to see on Smowcode, do let us know, maybe in our forum. So begin creating your code. Now let's do one thing. So let's say you want to turn an LED on whenever a button is clicked. Okay, and turn the LED off when another button is clicked. So what do you want to do? The activity is what? Turn the LED on. So we need to do a pin write. Now, pin write is called a pin write node. It comes up when you write the word write, or you can drag and drop as well. So our job is to increase your speed. That's what we ensure that we are focused on. So we so you can even drag and drop. I just go ahead and click on my arena on the Smowcode canvas, and I just click and I just search for the node that I need. Drag and drop is also something we can do anytime if you want. We can search here as well. So yeah, I've put the pendrive node. I'll just double click on it and I'll configure it to write onto pin number 2 or logic level 1. So I want to turn this LED on. Uh, Now when do I want to turn it on? Now that's where the event node comes. So the event nodes usually are named starting with on, click. So on button click. So there's a button which can be, so buttons in embedded systems can be attached, connected to one pin of the microcontroller. So we will choose pin number 0. Now the button is connected to which part, which of the lines, ground or VCC? VDD. That we need to specify here. By default, there's so we on Smowcode you can code the ESP32 microcontrollers as of now. In future, you will see more and more as well. If you're watching this video for some other microcontroller, you should you can use the button. You can just take the data sheet of the module that you are using, and in the module it will be written with in the data schematic of the module it will be shown whether the button is connected on the other side to the ground or to VDD. One side of the button, it has two pins. One side has to be connected to the microcontroller's GPI pin. Another side is connected to which one you need to know. So it's connected to ground, and automatically because it's connected to ground, it has the pin of the button, the other pin of the button has to be pulled up. So automatic pull up, pull down is enabled. Now what is this on part here? So if this checkbox should be enabled on some condition, let's say x equal to a or x is greater than uh, 5 or something, then we can put these conditions here. That's why this area has been created. So yeah, we're done. Now we'll just connect these. So on button click 0. Upon this event, this node will be triggered. Now we want to do the same thing, similar thing with another button. Let's say it's connected to pin number 13. Done. And pin level 0. Now that's how you think of the logics, okay? What was the activity that you wanted to do? Turn it on, turn it off. These were the two activities. When did you want it to be executed? When the button is clicked. When this XYZ button is clicked, when this ABC button is clicked, you can say when turn on button click. You can even do something like this. Internally, it is doing the same thing. You can just name them as how you understand the situation. And turn off button is clicked. Yeah. This is how you can code your microcontrollers. Now you can go even more. You you know now how event-driven system works, and this is how our mind should ideally think. Now, how does our mind usually think in case of C language? Is that like we need to create parallel work, we need to create parallel environments, we need to create parallel logics for parallel sensors and actuators working together. What we usually do is end up doing is we end up trying to create sequential logics for parallel work in C language by creating loops, by trying to bring multiple activities into a single loop that's just going on running and running and running, which might not give a good parallel effect. In case of Smowcode, they both run parallel. They both are interrupt based, by the way. Uh, so usually in case of C language, because the coders are quite lazy at times, they end up making the coders end up making polling. Now that is not something that is the best way. Uh, we need to ensure that that whatever code we make is of highest efficiency, and to avoid any such items that, let's say, you don't have time, let's say you don't have you don't have the bandwidth from the company, and you have to create a quick logic, and you end up making a polling logic that might consume CPU resources more than you think, and it might even cause trouble running other work. So what we have done in Smowcode is every event is interrupt based. For almost all of them, they are interrupt based, or they are FreeRTOS event based. In which case also they are event based, you can say. Okay, because FreeRTOS is a very good polling. Has a very good polling function that is very efficient, and while it's polling for some event, it can run other tasks as well. So this is how you should think about Smowcode, and how you should create flows on Smowcode. These are called two flows, by the way. This is a flow, this is a flow. Now we've covered the idea of Smowcode, we've covered the event-driven system on Smowcode, how you should be approaching a problem is something we've covered. Uh, a few basics of flowchart. Um, while one item is running, the second item doesn't run, the third doesn't run, the fourth doesn't run. So one at a time things run. It's all sequential. There are arrows which tell the sequence, uh, so that you should know. In case of flowcharts, there are if conditions which can take different paths. So if the if condition, let's say, says a is less than 5, okay, before that we'll have to create the variable here, if this guy will show an error. So in Smowcode you'll see an error over here if a variable is not made. So here we have a is less than 5. So once we have made the variable, we once we, what we say, try to compile the code, this error goes away. Um, yeah, so let's say a is less than a is equal to 0 and a is less than 5 is the condition. So this if part should run. So here we can display, let's say, a was found to be less than 0, 5, and here a was not found. So this is something that we can do on Smowcode, just as how we used to do in a flowchart as well. Now, after these two have run, we want to run a common thing, which is, let's say, and we successfully ran the program. Now, these once both the if conditions are, so if it so ideal, so what will happen is, either of these will work. In our case, because we have hard coded the value of a to be 0, the if flow will work. So the if flow will work, and then we successfully ran the program will be printed on the screen. Now, uh, if you see, this is how flowcharts have had been working, even when we draw it on paper. So whatever rules of the on paper flowcharts are there, almost all of them, except for how exactly the loops are made in normal flowcharts, except for that, everything else of flowcharts, all other rules of flowcharts are majorly covered in Smowcode. So you can think of yourself creating flowcharts itself as it is directly. Um, in case of loops, so how to create a loop on Smowcode. So, acha, by the way, if you just put the node display, hi, I'm being displayed over here. So this is an activity. So by the way, we call the nodes which have an input bubble, regardless of whether it has an output bubble. Uh, a node which has an input bubble is called an activity node, and a node that does not have an input bubble and just an output bubble is called an event node. Now, this is an activity node. We've created it. We are using an activity. It will not work at all until it has been triggered by the event node. So code kept like this will be fully ignored by the compiler as well. It will never go into the microcontroller only. It has to be given an event, some event. Let's say every 2 seconds we are displaying hi, I am being displayed. Now it will get displayed. Yes. If I remove this, it won't get displayed. You got the idea. So it's event based and it has to be thought of as when, what should happen. And it's nothing but flowcharts. I'm just explaining how flowcharts used to work. It's not a new concept. It's just something that you might not have been doing so often. So that is one thing. Then there's so we've covered how flowchart works. Yeah, about loops. Yeah, we were on loops. How loops work in Smowcode. So there are loop nodes available here. Wait, yeah. Uh, so there are loops. Yeah, we have loop nodes here. So you can, so just like we make loops in normal coding languages, we can do that here as well. We can start a for loop. Again, by the way, I have not connected this to an event node. This will not work. And I can connect it here as well, by the way, and it will work whenever off button is clicked. I'm just showing you. I'm just explaining you these how these concepts work on Smowcode. I'm not running these concepts because they have been covered with running as well in their own separate videos. My job here is right now to explain you the concepts more than showing them that they worked and exactly what more that they can do. I'm giving a top level introduction to Smowcode. So you can create a for loop just like you have been in your coding language. You can set the initial value of whichever variable you have. So let's say the variable name is I. If let's say you want to name the variable as J, or let's say my own name Adhik, or let's say Smo. Okay, you can do the same as well. You can just say the initial value of Smo should be 0. The condition should be Smo is less than 10, and the increment decrement should be Smo plus plus. And this will work just as if we have begun for loop, because anything and everything that you create on Smowcode gets converted to C language. It will uh, be the user experience will remain the same here for loops. When you start a flow, you start a loop, be it a for loop or a while loop. Um, you'll have to end it as well. And between these two, you'll have to create your other flows. So you can put a continue statement, you can put a break statement as well in Smowcode. Um, you need to know how exactly in the separate tutorial video uh, for loops and in Smowcode, you will see how exactly they can be made as well. So let's say we display here the value I, sorry, the value of Smo every time. The value of Smo on each loop iteration is, on this loop iteration is plus 1. So just like in Java or JavaScript or Python, I don't know about Python, in Java, JavaScript, um, you can concatenate with a plus operator. You can practically concatenate anything. You can even do small multiplied by 1000 divided by 10. You can create a formula here, let's shift 5, or you can go hex as well here. You can do 0xx, 0x10, and this will work right off. You would not need to worry. And what the output will be, the value of Smo on this loop iteration, in this loop iteration, is Smo into 1000, whatever the answer of this calculation is. You can even put this in bracket to not create any confusion. And you can even go on appending mode is this, and uh, and we like this software. You can say this like this. And this entire concatenated output will be clearly created on Smowcode. Now, while we are working on increasing making your user experience on Smowcode better and better every day, you will soon see Smowcodes. These flowcharts can also be created in vertical format. That's something we have in our roadmap as well. We are going on increasing the speed and your efficiency in creating flowcharts. Um, yeah, so we've created this flow. This flow can be triggered whenever the off button is clicked, but rather I just go and say every interval of, let's say, 5 seconds, let's just print this line. That's something that we can do. To avoid any mathematical issues, I'll just convert this back to something that is sensible. So this will basically get multiplied by 100. You can do all types of operations. You can go to docs.smoko.com to learn the kind of operators you can use. Broadly, you can use 99% of the operators that are there. There are some 40-50 operators that are there in any coding language. We almost do we almost support 39, 49, whatever the minus one or two maybe max that we don't support. Um, Else everything else is supported. In general, all logics, all the mathematical operations are supported. Might not be that if less than is supported and greater than is not supported, still you can get your work done types. So you'll always have a workaround. But yeah, by the way, for the record, both less than and right greater than are supported. This was just an example. Um, okay, you got an idea how a loop can work. Similarly, you can create a variable as well. By the way, set value node is your go-to node for creating any variable. Okay, we created a variable here, a equals to 0. We could have created a variable I equals to 0, and we could have done a start while, and we would have said that I. By the way, we have automatic suggestion. If you have connected your flow, then by the way, I double click to open this properties bar. I forgot to mention at the start. So when so when a flow has been connected to the when a flow has been connected, then you can get suggestions of variables which have been created in the previous nodes, which are accessible in the current node. So I, we can do less than 10. And similarly, we could have also done I is equal to I plus 1. Yeah, copy my control button is a little out of order. So I'll just go and type I is equal to I plus 1. Because it is an equal to sign, there's an equal to sign, we would not suggest you to do I plus plus. And we could have done the same thing here as well. Okay, we could have made this entire for loop thing with for loop flow with while loop as well, by the way. So that's how we conclude for loops. We've concluded while loops. We can do loops. Uh, we strongly suggest you if you do not make while one loops. You do not need that. Either you need to do something every interval of time, then just specify any number of on interval nodes you can put, and you can get activities running on whatever amount of intervals that you have. You can go as small as you want in intervals. In a free RTOS provides a timer range up to 10 milliseconds. So if you have to go till let's say every 0.01 second, you can go using the on interval mode. Below that, you can create. So upon start of the software, uh, you can create a while one loop if you want, which will be the fastest. While one is the fastest. You can create on Smowcode, it will run just as if a normal while one runs. And the while one will run at the fastest speed. And in the while one, let's say you're making a while one, you have to by the way end the loop always. Uh, yeah, if you're making a while one, you can put a delay inside it if you want to make it run every some time. Okay, and you want to add something more as well in between. Anywhere here. So you can put a delay. Delay can go as small as you want. So it can go till 1 microsecond, I guess. Yeah, it can surely go up till 1 microsecond. Everything is made here in seconds format for ease of use and to not confuse on how exactly uh, each type of delay works. There's no separate delay made for microsecond, no separate delay made for millisecond. This delay is very smart. It if it's let's say a free RTOS range delay, let's say 1 second or 2 seconds, which usually will be the case. Uh, so it will use free RTOS delay, where it will be a non-blocking asynchronous delay, which is the best that you can get. If you go below 0.01 seconds, which is the frequency at which free RTOS runs, which also can be configured by the way in the menu config part, there is component config, there's free RTOS as well here somewhere. You'll find it here and probably there'll be free RTOS somewhere here. And I just write this my tech people footnote. You can find this in a new in a different um, video where how to use and how to um, configure the RTOS is how to do that on Smowcode is shown. So yeah, until you're here, it's using free RTOS. After this, it's a blocking delay. So this is the delay provided by ESP IDF. Smowcode uses ESP IDF internally to compile your codes onto for your microcontroller. We do not use any other third-party uh, compilers or even libraries. Smowcode uses ESP IDF libraries. At max, Smowcode wraps them at times to make it more efficient and more user friendly for you and also more efficient, more professional at times. Um, but in any case, Smowcode does not make it less performant. In any way, you can download the source code and you can even tweak the libraries whenever you want. So we have flowchart here. I'll just take a break and we'll get back. I'm back. So now just to show you the output of what we have created here, we have the serial monitor open right now. So ESP32 runs, it starts with these information being shown. Now every 5 seconds, this loop iteration goes from 0 till 9, which is as expected. Now I'll just click the boot button on the microcontroller, and when I click it, we can see our output coming. And do you notice that when we click and whenever we click, the output gets shown for the value is less than 5 and successfully ran the program. And meanwhile, parallelly, the on interval 5 seconds flow, that flow where uh, for loop was there keeps running. This is all happening parallelly. You did not have to put any efforts to make this run parallel. You just had to specify the logic. It's happening parallel. And sequence is also being taken care of. So both sequence as well as parallel can happen on Smowcode. That's what we have made for you. Okay, so we have completed loops as well. Now let's learn a little about branching and merging. So if you notice here, uh, wait, I'll just do one thing. I'll just click the video of me pressing the play button. Yeah. So we have finished with a few things. We just need to go ahead it. Let's learn merging and branching. Over here, we have quite a lot of code. Let's just remove a few of them. Now, let's say we want to, on every 5 seconds, we want to make LED an LED blink. Okay, so we'll again pull out a pin right node. Okay, then we will put a delay as well. That blink should happen only once. Okay, the blink should be very short amount of time. Let's say 0.01 second. The blink should happen. The LED should stay on for only that much amount of time. So over here, if you see, we have turned on the pin number 2. We are uh, we are waiting for 10 milliseconds, and then we are turning it off. Now this means that the LED will blink for a mere 10 millisecond period. Okay, regardless of its state, where it was in over here, whether it was on or off, it will turn it on and turn it off. This code will turn it on and turn it off. Now this code will not run. It will have to be connected to some event. Okay. Now what we can do is we can branch out from here, and this code will run in parallel to this code. Now this is one place where we can make it run parallel. We can also do it every iteration of for loop. So every iteration will cause the blink to happen, and it will blink 10 times. Now let's say if this loop had to run with a delay in itself with of about 0.1 second, let's say 100 milliseconds. Okay, so every 100 milliseconds, by the way, this will get printed, and every 100 milliseconds, this loop's iteration will run, and on each iteration, this blink code will run. We can also put this blink code over here. So we can branch out from anywhere to create a code that is running parallel to the code from where we branched out. So this is called as branching. You can create as many branches as you want. Each branch, by the way, will create a new task. Okay, the original place from where you created the branch will remain as it is. That is okay. Yeah, by the way, I forgot to explain you how Smowcode tasks work, and how internally Smowcode manages your flows. So over here, what you see, except for the event node, is somewhere or the else inside a task. Okay, so over here, this entire flow is one flow, and this entire flow is part of a task, one task. This is in another new task. This one is also in another new task. Okay, and until here, it's in the same task because the loop is always there in one task only. You You cannot have a loop spanning across tasks. Only in one task you can span it. Then there is this part. This is a branching out of a non-loop part from a loop part where this new branch of flow should get executed on each iteration of the loop. So what Smoker internally does is it sends a notification to this new task every time the task has to run. Okay, this branching out has been made. So just between the code of this displaying of value and the delay, this there's a notification sent from the below task to the new upper one task. That's how uh, internally Smowcode arranges uh, your activities. Okay, so if you want to ever efficiently use tasks, you can eliminate using a task by sequentializing. So this 0.1 second might not have been such a big thing. Sorry, the creation of the blink might not have been such a big thing. We could have placed the blink right in the middle of this task as well. If you want to make it a little more efficient, your code a little more efficient, you can reduce your branch outs, which will increase your efficiency. Uh, and You don't usually need to do this in a low scaled code. You in a small code you don't need to look for such efficiencies, but in case of bigger codes you might want to reduce your number of tasks. So in that case you can choose to put uh, to use as less branches as possible, but for your comfort always choose branching. As much it is working, let it work. Okay, it's being handled by Smowcode. You can also prioritize your tasks. So if let's say this entire task, this entire flow, you want this flow to run in high priority in FreeRTOS, do look up FreeRTOS priority once. So just in case this flow has to run at a very high priority. Okay. By default, all tasks in Smowcode run at priority number one. And let's say this new flow has to be run at priority number 5. So we can begin this flow at a high priority, let's say priority 5. And anytime this flow runs, it will run at a priority of 5. So let's say any priority 1, 2 or 3 tasks are running on the side, those will stop running and let this task first run. That is what uh, beginning the priority means. And until the end or until the priority is again changed back to what we say 1, the priority will remain the same throughout the flow, beginning from the begin priority node. So let's say if you put this back to 1, so from begin priority 5 to begin priority 1, the priority of that part of the task will be high. Okay. Uh, so yeah, if you don't write begin priority again, that means the entire flow from the begin priority part stays at priority 5. We don't need to do that right now. Similar is for stack size. You can begin a stack size as well from anywhere. Okay, this task should increase the stack size from one word. Let's say we want it to be 2048 words. By default, by default the stack size for tasks are kept as around 4096 or something. We'll just check it and let you know in the comments if you have any doubts. Uh, Same goes for the core. If you want to select the core on which the task should run or the flow should run, specific core. Usually the core is by default, Smowcode makes tasks for your flows on random cores. Okay, so if any core is free, that core is used to run your task, which is an efficient way of running a task as well. But sometimes you might need to run one task in one core and second in the second, or let's say one task in one core and all the other tasks in the other core itself, so that one core is always fixed and running your that important task. Okay, for example, it's handling your Wi-Fi or energy metering readings. uh, this can be done here. So that way you can use the advanced 3 stars nodes for your help. Now, so yeah, this is how branching works. Now, this is how branching works. So, I totally, I'm thinking that you understood how and what branching would mean. Uh, I'll, I'll, I'll just go ahead with this. I'll just show you the output once though. Wait, I'll just click upload. So now, during upload, when building is happening, that means your flow is being sent to the servers of Smowcode. The servers are very efficiently and in a very secured way are handling your flows and are creating a C code out of it in a non-Gen AI manner, in a very deterministic manner, and then they are being converted to binary. They are being sent back to you. Yeah, it's sent back to us. The binary is obtained. Now the actual flashing is being taken place. Now, once the flashing will finish, we will be able to see our output on the serial monitor as well as on our ESP32. Now we'll just go to the serial monitor, click connect, and there we go. Yeah, we can see now how so many blinks are happening on the ESP32 super fast speed every 5 seconds, along with the output on the serial monitor. See, it's happening parallelly. So that's how Smowcode works, the branching part works. Now let's say we wanted to make this blink happen, uh, rather than turning it off on the off button click, we wanted this blink to happen and then at the end obviously the light should be turned off. Okay, upon click of off button click. Okay, so now what we can do is we can just connect the off button click node directly here, merge it in the flow of pin to the blink code. Okay, so this blink code over here, let's just write here blink code. So there is the blink code here, and this blink code is the one which we want to execute every loop iteration as well as whenever uh, off button is clicked. So this way we can comment it out. We didn't have to copy paste for both when off button is clicked and even when um, the loop iteration happens. We didn't have to do it for two places separately. We just had to do it once and call this, notify this task every uh, iteration as well as every time the off button is clicked. This is how you can merge as well. Now, how many times will this code run? This will run every iteration as well as when off button click. This will not run when both events happen and then it will run once. No, not like that. It will run separately for when off button is clicked and separately for when uh, the iteration happens. It will not wait for both the events to occur for it to run. No. This code will run whenever any event has occurred. Okay? And you can keep a queue as well. So let's say the off button click event has happened, and while that has happened, the uh, the iteration has also taken place. Now, what to do in this scenario? Which one? will run, and let's say if the task that is running over here has not finished yet, then every task is can only run. Uh, so in Smowcode, a task cannot be notified. Sorry, it can be notified, but the notification will not trigger the task until the task has finished doing its previous uh, task. So let's say previous activity. So let's say the activity is to blink this LED. Now how much time will it take to blink the LED? 0.01 seconds. Now within the 0.01 seconds, we notify this task for more than once. Okay. Then the first time which when we notify, the task will run obviously, and the second time when we notify within the 0.01 seconds period, uh, when we notify, the task will not begin running because it is yet to finish the previous activities that it was doing. Okay. uh, Now what will happen is the notification will stay in the same task. Okay. This flow is a task, by the way. Okay. So now the new notification that we send, the second one, it will still stay in the task, and once the task, the first iteration of the task is finished, during the second iteration, second execution, okay, a second execution will be attempted for for this task. Okay. Similarly, at max, if you send 10 notifications to the same task, okay, to the same task, before this task has finished doing its one full activity cycle, then only one notification will actually be saved, and it will be run the moment the entire cycle of the task has finished. Okay, by default, this is the case. So there's only one storage of a notification in case a storage of notification is required. Okay. If you want to increase the amount of capacity of notifications that can be saved just in case notifications are received, let's say 10 times the button was pressed within the 10 millisecond period. Okay. And you increase the queue capacity. This is called a queue capacity. So it will queue the events being sent to the flow, the blink code. Okay. So now, if this guy sends 15 events even before this blink code is has finished executing one events code, okay, the 15 events will be saved. Okay. No more new events are being sent by click, let's say, uh, and the 15 events which are saved in this queue, queue as in QUEUE, that queue. So let's say the queue is having 15 notifications saved, and no new notifications are being sent by button clicked no. Then all those 15 notifications that are present in the queue will be one by one executing and triggering this flow again and again and again and again. Okay, that's how it will go. So now your events will not be dropped in case the notification queue of size default size 1 has been has finished or has been used up. Okay. Similarly, you can put a queue here as well. That is how you will be using queuing and how notification of tasks, how branching, how merging works. You can do this anywhere, anytime. Even here you can do it if you want. Although queuing is not allowed inside the loop for reasons that a new task is created anytime you choose a queue. So new tasks cannot be created between a loop because a loop cannot span across tasks. Always remember this. So now we've worked with merging, branching. Now let's learn how properties work and how we can get uh, the information created by nodes. So some nodes read values from, let's say, pin. Okay, this is a pin read node. What is its job? It has to read the pin and tell us what it read. Okay, how will it tell us? Okay, in the program, let's say we want to display whatever the pin has read. Okay, how will we read this and display as well whatever the pin value is 0 or 1 on the particular pin? So first we have to say which pin number, whether it's pull up only, pull down only. In this node, this is one example node that we are choosing, and then it gives an output inside a variable. Smowcode has variables. Yes, Smowcode is just like any other coding language. It has variables, it has expression, it has formulas, it has everything that you need to work with data. It has arrays as well. Smowcode has arrays as well. Do check out the video for arrays. So here, in this variable, whenever this node has finished executing this variable, the output will be stored. The output of the pin level in this case, and we can change this name as well. And this exact name we want to print here. So we'll get the suggestion of the variable always. The pin level that was read is equal to plus pin level. No, I just hope this was the name I forgot. Yeah. So yeah, there we go. So now this again will have to trigger obviously. Um, so let's just say every 5 seconds we also want to know the value of pin. Okay, so it will tell us the value of pin every 5 seconds. It will read the pin number 0 and it will say this is the pin level that was read, and this will run in parallel to the value of this for loop flow. Now here another task has been created. Again, it's totally fine, totally normal. You can do it. It's just my responsibility to inform you for you to be able to create efficient flows. Um, cool. So this is how you can use the outputs. You can't just do this. You can also do even more items. Let's say whatever the output you receive, you can multiply it by 1,000. Again, you can create any formula that you want. You can left it by 10. You can do any sort of math activity. You can convert this number to text. Uh, this number is anyways automatically converted to text here in this scenario. Um, then what you can do here is you can add more concatenation just like we did the last time. We have the set value node we can also do, we can use an if condition to check whether or not that pin level, if it was 1, if pin level small is equal to 1, then let's do something. Yeah, it was on. So pin level was 1. Else it was 0. So this is the way for us to create a flow using the pin level that was obtained from read pin. Just like this, there are so many other nodes that keep generating more and more outputs. Okay, for example, we get a JSON. For example, we use a map node. So this map node accepts a variable as well as, by the way, everywhere and anywhere, almost in all places, you can give a variable name or an expression. Okay. In all activity nodes, the expressions are allowed in all uh, in all activities nodes you can give an expression, also a variable, okay, and obviously constants are allowed in all types of, in both the types of nodes, events as well as um, the activity nodes. Now we'll learn something that's, I'll just show you regarding map function first. I just thought of a point that I can tell in this video, so I'm just noting it down. I've noted it down now. Um, yeah, you are at the map node. To the map node, you can. So let's say you read the pin and you want to map whatever pin level that you are receiving. That if it is 0, so the inputs are from 0 and 1 to 1. Actually, they are either 0 or 1. Let's just say that they were from 0 to 1, and you want to map it to minus 55 to 555. Okay, so let's say 0 comes, it should be translated to minus 55. The value, the output value should be minus 55, and 1, then 555. Okay, so this analogously, this map node over here converts from this range to this range of this value and gives it out in the variable named map. This so we also sometimes want to know about the data type that is being output by the node. So over here it's written in the uh, tooltip that this is the map's output value and it's of type flow. Now whatever the mapped output value that we receive, we can print it over here. So let's say the pin level that we read was the mapped pin level is nothing but the variable map, and that's how we can display the map value. So you're getting anywhere we can create tasks. A new task is not created if you're using if conditions. Okay, by the way. And over here, when we created the if condition, we also sequentialized it and commented it out into one node. This node will only run once. This is sequentialization of an if condition, which is a concept out of flowcharts, not of Smowcode. So if only one of them will run at a time, which is why this will only run for one branch. And again, it will not wait for any of the branches. That the rule of merging still applies here to a level that if any of the events occur, this will run. But because we know for a fact that only one of them will occur, this guy, this new node was put in the same um, task as was the other elements. Okay, so your if conditions for loops are very efficiently handled by Smowcode smartly. But yes, if you choose to branch out from here, then obviously a new task will be created. Okay. Um, Now we were on, yeah. So this is the new flow that has been created. Again, I will not get into the nitty-gritty of the flow and the outputs for now. I'll now teach you something that's a config now. Okay, see. Now let's say you you're using UR. I just drink some water. Yeah, let's say you're using UR. UR requires you to, we call it serial by the way. Serial has its own length, a lot of nodes that we have in serial. So let's say you want to write something to your serial code. Okay. Now you will need to configure the serial code, and you want to call this serial write multiple times. Okay. You want to call the serial write with the data that you want to send. Okay. Multiple times you want to do this because you want to send multiple types of data, multiple variables that you want to use here, let's say some XYZ variable that you have received from somewhere, plus is also part of the data. Uh, this is also something that you want to send. Now, while calling these so many same type of nodes for the same exact code, would you like to configure the UR put every single inside every single node? No. You would like to store its configuration in one place. So that is this one place, serial port. let us configure it. So this is a configuration node that has been made, and this node is present over here, okay, on the right. So if I just press cancel, yeah, this is that node. And who is using this node? This config node? These two nodes are using it. So if you just hover over the config node, it will show you what they, uh, who is using them. Now just understand here. Here there are these so many functions that are there. This clock source frequency as well, clock source as well, which clock source has to be used. To the very bottom, so Smowcode is advanced. You can go to the very bottom. How much ever is provided by ESP whichever settings are provided, has been given out here to the level of the buffer size as well. Okay. And other third-party applications who allow you to code on ESP32 do not provide such depth of configurations. How only the ESP and Smowcode provides, and Smowcode provides it in an easier way. Any other easy coding language or a quick coding method or a quick coding language or an education-based coding language uh, might not have the feature of industry-grade advanced features. Smowcode has it for free. It's also available in a free version. Uh, so here you created all the configurations and you kept it in this config node, which is used by these two nodes, these two activity nodes. They are also used by event nodes. So there's an event node in serial on receive. Even that guy uses the node. By the way, an error came because we used the word XYZ, even though it wasn't present. Let me just put XYZ as the data received from the event node on receive. Okay. Anyway, now the thing that you saw is both event nodes and activity nodes, which are on the canvas, they can use config nodes. Okay, and whether or not someone has a config node or not is the decision of the person who made the library. Okay, so if the library asks you to create a config node, you have to make a config node, and then automatically any new node that you drop down from the drag down from the palette regarding that library will mostly be using that same config node. Okay, automatically. I did not have to configure these three to use this config node. Although you can make multiple config nodes as well. Let's say you're using serial ports, 3 serial ports. Okay, so now you'll have to create another config node. Here you have to create with new serial port, and let's say the new serial port is working on 9600. So this guy is using 9600. This one is using UART 0 115200. That's how you can choose multiple ports as well on Smowcode. And you can talk to so many different ports on Smowcode. Now, oh, yeah, it automatically updated to 0 Uh, yeah, you got an idea. Now the thing that we used to say that activity nodes have an input bubble. Uh, Event nodes have zero input bubbles, maybe an output bubble. Obviously, it should have an output bubble. But configuration nodes have neither an input bubble nor an output bubble. Always remember. And they are always present in the config nodes area. Sometimes when you use the same flow for a different project and you delete all these nodes in the canvas area, okay, but you forget to delete the nodes that you created for the canvas area nodes in the config nodes area, then these nodes will initialize some ports even without you having the hardware features connected um, for those specific libraries. For example, in case of I2C, if you begin a comport, if you begin using an I2C node, and you'll require it will require you to create a config node for the I2C canvas nodes as well. So event nodes and activity nodes become canvas nodes. They are called canvas nodes. Now, whenever you create the config node for I2C, Okay, I2C tends to expect a hardware to be connected on the specified port that the I2C config node is using. Okay, and it initializes by trying to converse with the I2C peripheral ones. Okay, or let's say if you are choosing LCD, or let's say some peripheral, okay, which is connected on I2C, and you are trying to initialize it with, you're trying to connect to it using some nodes on the canvas, and there's a config node which actually does the initialization part. Okay, if that is the case and you have not put your you have deleted all nodes from the canvas, but you forgot to delete your config node, then when you upload the code, okay, with all nodes deleted but config node present, the config node will still try to initialize and try to talk to the expected peripheral that it was supposed to talk to. Okay, so always delete config nodes whenever you are deleting canvas nodes. Um, okay, now regarding how, yeah, let's move on to the new tab. Um, So we are covering quite a lot of interesting topics on Smowcode that will help you uh, get a glance of how rules in Smowcode work, how we need to ensure a few small things that are that might cause issues while you're writing code. Although these are very basic and uh, things that are there to help you. Um, so we'll work with the config mode. How expressions work. Expressions work anywhere. Acha, expressions are not allowed in config nodes as well as inside event nodes, because event nodes cannot take input from anyone, right? So here you cannot add expressions. You cannot write that line ending character is based on some XYZ or ABC variable. No. It has to be a constant. You can put a global variable. You can try. I don't know if my tech team has allowed that. Even in config nodes, we cannot be dependent on any variable because they don't take any input from anywhere. Now, how initialization works. Now, you might be thinking who initializes the pin to output. You might be thinking who initialized the interrupt, who registered the interrupt in case of on button click, or let's say on receiving line. There was a UART interrupt registered here, by the way. Who did that? So whenever you drag and drop a node and compile it, the compiler of Smowcode creates two codes, not just the code to run what activity you are doing, let's say pin write. So it will not just write a code here to to set the value of the pin, but it will also write the initialization code at the right place based on the node that you have used. It will automatically create the initialization code as well. So each node that you pick has two things: initialization code as well as the main code. So that's how Smowcode automatically initializes. When you will make your own libraries in Smowcode, you will get a chance to create the main code via inputs and outputs on Smowcode, as well as the input and output, as well as with the with an init node. So between input and output goes the main code, and from the init goes the uh, init part of the same node that you are willing to create using Smowcode's library creation tools. You can create your own nodes using Smowcode. There's a different video for that. Very easy to do. You should watch it. It will save you time. Um, and also how to create a config node directly by creating properties for the config node, any internal config node that it should support. There's a separate video for that. So we've covered how initialization automatically works for all the libraries that have been created on Smowcode. Now the level of flexibility that works in Smowcode. that that's there in Smowcode. In Smowcode, let's say you want to get into uh, you want to get into a library. What you can do is you can create the source code. So you can download the source code, you can get into the library, and you can change whatever you want first. Second, let's say you want that library, you want to change that library and use the change library always rather than you having to create the source code all the time. You can paste that library inside the same project. So let's say we can create a new file here. So see, main.smo was there. With that, we created a .c file, and here you can paste your library now, your new library that you made from the old library itself, by taking full inspiration from that. You copy pasted that library here, and now you can utilize whatever functions are there in the C language inside small language itself. So over here we can just type small extern, and this custom function that was here is now available in the palette, and bingo, you can use it in Smowcode anywhere you want, any amount of times that you want. It's just a library. You can there are ways to create these functions. There are ways you can specify inputs and outputs of these functions, and how you can utilize it in the best form, uh, and how you can integrate your own libraries or even the modified libraries of Smowcode that you do uh, into your code, and then you don't have to worry at all ever again. Your codes will have that new modified library. That's how we provide flexibility to you. In on the right, if you see, this one project has files. You can even create more and more flow files, okay, and save them. And your project will keep going on containing more and more flow files. A combination of flow files, C files, H files, CPP files, along with an entire folder of a library that you can upload from here, uh, they all will at the end result into one project, one binary file which will go into your uh, microcontroller. That's what we made for you. That's how Smowcode ensures flexibility to you. Even legacy codes can be pasted. These all codes should be ESP-IDF compatible as much as possible. By ESP-IDF compatible, I mean is they should not hash include Arduino's libraries. They should not hash include something that's not available in ESP-IDF or naturally available in any C language code as well or CPP code. Um, So you also understood what properties do, how outputs are there in each of the in all the nodes which do give outputs, how flexibility is given. Now let's go to uh, let me give you a very quick brief of how a library can be created on Smowcode very fast. So input. So let's say you want to create a library out of this part. Let's say not this part, this part. These two guys, we want to put it inside a library because we want to use it at many places in the flow. Okay. So we will just put it between an input and output. So this input, let's just name that you should be part of a new library. Okay. Okay. You'll see a little complexity in terms of how Smowcode manages to store the data of the new libraries that you create. Okay, so yeah, you want to create a new library, you create a new library, you name the new library. Let's say the name is small new library XYZ, and let's say it should have a property of type ABC, um, whose default value should be 0. Okay, creating a library on Smowcode will ask you a lot of information. Now, do note, the more the information you provide to Smowcode regarding the library, the better it is for the users of the library. That's where Smowcode is smart as well. So as much information you provide to the library, as much is the information present with Smowcode, then for it to show to the user of the library, which might be you or you're making for some other or for your community, okay, it is better for that user to the user experience will be great. If you let's say don't write documentation, the user experience will be bad. Write the value of data to be sent to you. So you should buy serial code. So this is something that you can. So as much as possible, you should be giving what we say data to Smowcode. Whatever is the data type, it's in 32, in 32. Okay. If there are any output values, let's say you are giving out data. Okay. Some some output buffer data. Okay. And you should be writing here. And it's of type array uint and add. Yeah, you've created a node now. Now, obviously there will be errors because XYZ variable hasn't been present. Rather, ABC variable is present. Uh, yeah, ABC variable is present. So ABC might be a variable that we can choose to use here. And we have to terminate the flow as well. That yeah, this is from where my library starts and ends. This is the input bubble to the output bubble flow of how it will be inside my library. Now this library has been made and it's available here. I can change the color as well of the library by the way. I can go inside, change the color to something that's a little more RGB, a little more blue, a little less, um, let's say, yeah, a little more blue. And yeah, we got something in blue color. Now, obviously, I didn't choose the best color, but yeah, you can understand we can choose the color of the library that we want. There are more library features as well that you'll find more descriptive in a separate video. And you can call this library from anywhere. Now, let's say if you have created a library in Smowcode and you're using it, and you don't want to go to the code by scrolling, you can just do a control and click and it should, so because we are in the same flow it might not work well, but yeah, if I just use this library in a separate flow and I do control click, it will make me reach to the flow where the library was created. That's what it was basically. So yeah, we could create a library very easily for the same node. If we have some init code for the very same node, okay, then we can say that yeah, so during initialization we are initializing our my node name small. Let's say initializing inside the init part of our small new library XYZ, and this init node should be part of small new library. It's the init node of this same library. We can that so now whenever this node will be called during initialization phase, this guy will be called, and during what we say during actual main execution, this part of the code will be called. So that's how you can very quickly, easily make libraries and modularize your code. You can modularize your code out from libraries, from flows in both ways. Uh, you can go multi-file just like you do in C language. Don't forget, by the way, that you're still coding. You still should follow the rules of modularization. You should follow the rules of keeping the codes clean, how they look, how they appear. You should still use Control F to find uh, your codes. You should still use the basics that you used there to gain some speed over no speed. So that you keep intact plus uh, what's there in Smowcode, that they both together will give you even further speed. So we are almost about to end our topics. Yeah, there are a few tips that you should note down. First is how to solve errors in Smowcode. We would highly recommend you to first, we would highly recommend you recommendations for error solving. So it's a quick list. We'll have a separate video for a big list. Just give me 2 minutes. Yeah. So for for solving errors, first we have a recommendation that you should surely go through the examples. Example templates of smoking should be working in your hardware. If not, then either hardware is not correct or example is not well configured as mentioned in its README file, if there is a README file. Okay? Some examples are obvious, they might not have a README file. Uh, then you need to ensure that you are reading the serial monitor in English. The serial monitor is black. The serial monitor is black screen, which is usually hated by developers. As in, obviously developers love black screen, but they don't like any errors that come out of the black screen. So that is the place where you don't need to hate it, you just need to read. If there's any error that might be in your runtime code, you can detect it. If let's say I2C could not be initialized, might be a hardware error, hardware connection error shown in the serial monitor during runtime. These are runtime errors. Always look for compilation errors in the errors sidebar. So we have totally eliminated the C code errors, and the 90% of your errors have already been taken care of. We just want you to still focus on the 10% that are pending, which might be from your end, which might be from a library or something. Just it won't usually be from the library because all libraries that Smowcode provides are tested. Um, just in case your libraries or your C codes that you have used, CPP codes that you have used are not well integrated, they might cause issues. So do look for compilation errors and um, the runtime errors. Then you need to ensure that your hardware errors are not there. Shouldn't be there. Especially in case of wrong or inadequate, or either wrong or uh, accidental connections, accidentally non-connections are made. So let's say sometimes even the jumper wires don't work. Even the jumper wires don't work. So this is something that we would like to mention here. Uh, Quality of libraries. Uh, so in case of Smowcode, we ensure that the libraries that we deliver to you are of highest quality, and they have so much information for you to be able to use it without having to uh, uh, worry much about how to use the libraries, which property there's toolkit for each property. As much as possible, we have ensured that they are documented well. But still, we would like you to check out uh, tutorial videos of libraries, videos of separate libraries, library separately of each library that you need to use separately rather than directly using the library all by yourself without any help. This is one kind of a feedback that I would have for you. We've seen quite a lot of people directly jumping on and using the library. It would be better if you see someone else use it successfully. That helps. Uh, that is one thing. Check out the tutorial videos and obviously uh, keep a habit of checking documentation. That's of Smowcode for rules of the coding language majorly, and also some expectations of libraries. Okay, hardware, let's say software, let's say inputs, let's say conditions, environment conditions, etc. Okay, do check these. This marks the end of this video. Thank you so much. We hope this was helpful to you, and we hope to see you increase your speed using Smowcode. This was just a learning session. Once you have it all in your mind, you'll be faster than, surely faster than how you were in C language. Thank you so much. Take care. If there are any feedback, do let us know.